Hi everyone. We have the first lesson for matrices. This is just the introduction. Yeah, so these are the cases I want to discuss briefly. So in the subsequent lessons, then we see how we solve problems. To start with, what is exactly a matrix? When we talk about a matrix, I'm discussing the definition. When we talk about a matrix, it's the arrangement of numbers. Yeah, it's an array of numbers, a rectangular array of numbers. It doesn't mean that matrix is all about rectangular type of appearance, but we have a square matrix, we have a rectangular matrix. But the most common matrices are those that are rectangular. So therefore, a matrix is defined as a rectangular array of numbers. The way the numbers are arranged is the reason we have the word array. Yeah, a rectangular array of numbers is what we mean by matrix. Now, how matrix appear? Now, we can have like this. For example, let's say 3, 4, 6, 2. This is an example of a matrix. You can write it this way with curve like this. 3, 4, 6, 2. This is an example of a matrix. Okay, it can appear like this. 4, 8 minus 1. It could be any value. It could be a letter like this. B, 0, 1 like this. It could be a 2-digit number. So this is an example of a matrix. This is an example of a matrix. This is an example of a matrix. Even this one like this. Let's say 2, 4, 3. This one is an example of a matrix. How about this one? 2, 1, 3. This is also an example of a matrix. Okay. Now, what we have in the matrix, what are they called? So these numbers you see, it could be numbers, it could be letters. Remember, a matrix is a rectangular array of numbers. A matrix is a rectangular array of numbers or letters. Very simple. So the numbers or the values, we don't want to say numbers because not only numbers we have in matrix. Yeah, not only numbers we have as the input values. It could be letters. It can either be like, it could be like, for example, A, B, E, F. This is an example of a matrix. So the fact that there are cases we have numbers, there are cases we have letters. So we don't want to say the numbers, we don't want to say the letters. So we have a general word, which is that. That is elements. Yeah. The numbers or letters we have in the matrices are called elements or entries. Are called elements or entries. Or entries. So what we have inside in the matrix is what we call entries or elements. There are 4 elements, there are 4 entries. There are 4 numbers, sorry, there are 4 elements, there are 4 entries. There are 3 elements, there are 3 entries. So the definition is that a matrix is a rectangular array of numbers. A rectangular array of numbers or letters. That is matrix. Okay, so this is how matrix. It could be of this form of bracket or the curved one like this one. I hope that one is clear. All right. Now, matrix, there are things we need to understand. But the most important thing in writing a matrix, don't write a matrix like this. For example, we say this. As if it is 34. No problem. If you mean 34, no problem. If you try to mean 28, no problem. But there must be a space. And before I discuss this one, matrix is known for arrangement of numbers into rows and columns. Into rows and columns. Rows go this way. Okay. Now let's say we have here 2, 4, minus 3, 8. This is an example of a matrix. So when you go this way, we say rows. The rows go this way. And this way we have what? The columns. Okay. So now the question is, how many rows do we have? How many columns do we have? Then we can say 1, 2. So 1, 2 means there are 2 rows in this matrix. How many columns? 1, 2. There are 2 columns in this matrix. Now, if we have like 2, 4, minus 3, 0, 1, 4. Yes. If I ask you now, how many rows do we have? Rows run horizontally. Horizontally. And for the columns, vertically. Okay. So if the question is to know or to, yes, to tell how many rows we have, just go this way. Yeah. So we say 1, 2. It means there are 2 rows here. There are 2 rows. How about the columns? 1, 2, 3. There are 3 columns. Is that understood? So in matrix, we have rows and columns. The rows run horizontally and the columns run vertically. But mind you, what I wanted to say before I thought of rows and columns. Mind you, make sure that there is a gap left between columns. For us to understand that this column is separate from this column, or there are separation, we need to have a gap. Do not write it like this way, as if you want to write 38, or as if you want to write minus 30, 24 or minus 38. Otherwise, this one could mean what? 2 rows, 1 column, because we cannot say this one is 2, 4. We cannot say minus 3, 8. It is just minus 38. This is just 24. So if you write it like this, it's like we have how many rows? 1, 2 rows. How many columns? 1 column. Because we cannot see this, we are in 2 and 4 at a separation. It's just like 24 minus 38. So gaps are left between columns. I hope that one is clear. Okay. Now the next thing is we have what to call order of a matrix. Order of a matrix, not O-T-H-E-R, O-R-D-E-R. What does that mean, order of a matrix? Order of a matrix is what? The number of rows by number of columns. This is what we mean by order of a matrix. Number of rows by number of columns. Usually when we write this one, it appears like a multiplication sign, but you don't have to say number of rows times number of columns. No. This is like when we say 4 by 300 meters, like sport meet. We say 2 by 400 meter or 4 by 200 meter, for example, an instance. So you can see a multiplication sign, but we don't say times. We don't say multiply. We read it, it is read by what? By saying by. Number of rows by number of columns. So this is what we mean by order of a matrix. Now, if you are to tell what is the order of this matrix, so ask yourself, but mind you, it is not an optional or a matter of choice saying, let me say number of columns before number of rows. No, it has to be in this order we are in, number of rows first before number of columns. So what is the order of this matrix? It's simple. How many rows do we have? 1, 2 rows by. How many columns do we have? 1, 2 columns. So we can read this one as a 2 by 2 matrix. This is a 2 by 2 matrix. So what is the order of this matrix? The order of this matrix is that try to understand how many rows first. 1, 2. There are 2 rows by how many columns? 1, 2, 3 columns. So this is a 2 by 3 matrix. This is a 2 by 2 matrix. I hope it is clear. How about this one here? Well, the same number of rows first. 1, 2. There are 2 rows. How many columns? We only have one line. Yeah, so this is 1. So this is a 2 by 1 matrix. I hope it is clear. So number of rows comes before number of columns. That will give us order of a matrix. So let's go to point number 3. That is types of matrices. Types of matrices. Let's come to the types of matrices. So the first one we have is row matrix. Why is it so called row matrix? Because it is a matrix with only one row of elements. For example, 2, 4, 6. This one is a matrix. Do not forget what I emphasized. Gaps must be left between columns. Now let's say here 3, 6, 2, 4, 8, 1, 3, P, Q, R, S, T, V. Okay. Now we are discussing row matrix. A row matrix is one in which we have only one row of elements. It doesn't matter how many columns. The focus is a matrix with only one row of elements is called a row matrix. Like this one, how many rows do we have? Once we go this way, there is no other line. We have only one row. We don't care how many columns are there. The fact that there is only one row of elements, we call this one a row matrix. This is another row matrix because we have only one row of elements. This is another row matrix. We have only one row of elements. Is this a row matrix? Let's check. So how many rows do we have? 1, 2, 3. So there are 3 rows. So this is not a row matrix. This is a row matrix, this is a row matrix, this is a row matrix. This one has only one row of elements. It has only one row of elements. It has only one row of elements. The number of columns does not matter. Okay. The next one is column matrix. The same thing goes, just the opposite. A column matrix is one in which we have only one column of elements, like this one. How many columns do we have? 1. Here again, the number of rows does not matter. The most important thing, you have only one column of elements. This one is an example of a column matrix. One column of elements, a column matrix. One column of elements, a column matrix. How many rows? It doesn't matter. I hope it is clear. Now we have what we call diagonal matrix. But I want to reserve diagonal. Yeah, let's go to something else. Let's go to rectangular and square. Now we have 4, 2, 3, 6 minus 1, 0. 4 minus 1, 3, 8. P, Q, R, 2 minus 1, 0. X, Y, 2. 4, 2, 3, 6, 1, 0. Okay. Now, we want to explain rectangular and square matrix. Now, before we go to rectangular and square matrix, let us reflect let's go back to geometry. We are in the discussion of rectangle and square. Of course, it's so common. This is a rectangle and this is a square. Okay. A rectangle and a square, each one has four sides. That is why they are what we call quadrilaterals. A quadrilateral is a four-sided figure. Any four-sided figure is a quadrilateral. Quadrilateral. This one is a quadrilateral. This one is a quadrilateral. But specifically, this one is a rectangle. This one is a square. So why this one is a rectangle? Because we have longer sides. Yeah. And the opposite sides are equal. They are not only longer sides, but they are also equal. We have what? Shorter sides. But for a square, all four sides are equal. So this one is a square, this one is a rectangle. Is that understood? So if this one is a rectangle, this one is a square. Now let's go to what is a rectangular matrix. What's a square matrix? Now let's go. So let's see how many numbers we cover here. 1, 2, 3. We cover three numbers. How many numbers do we cover here? 1, 2, 3 numbers. So three numbers, three numbers. How many numbers we cover here? 1, 2 numbers. How many numbers do we cover here? 1, 2 numbers. So two numbers, three numbers. Yeah, here more numbers, here less numbers. Do you understand? So this one, you cannot say this one is a square matrix, but this one is a rectangular matrix because we have here more numbers, more entries, more elements. Here we have less. I hope it is clear. So which one again is a rectangular matrix? This one here. Here I cover two numbers, 1, 2. I cover two elements, 1, 2. 1, 2, 1, 2. I cover 2, I cover 2. Here I cover how many? 3. 1, 2, 3. Here I cover how many? 3. 1, 2, 3. So 3 elements, 2 elements. More elements, less elements. So this one is also an example of a rectangle. Beware, rectangle doesn't mean that the top and the bottom has to be what? Have to be the longer sides, and the left and right have to be what? The shorter. It could be the opposite. The most important thing, longer sides equal, shorter sides equal, and they are opposite. So this is an example of a rectangular matrix. This is an example of what? A rectangular matrix. Now, why this one is a square matrix? Yeah, two numbers I covered. Two numbers I covered. I cover 4, I cover 3, I cover 2. 1, 2. So the same number of elements you cover in any of the ways. I cover 2, 2, 2, 2. I hope you understand. Here again, I cover P, Q, R. How many elements? 3. I cover 2, Y, X. How many elements? 3. Same 3, same 3. How many do I cover here? P, 2, X, 3. R, 0, 2, 3. So 3 elements covered, 3 elements covered, 3 elements covered. The same thing here. So this is an example of what a square. It doesn't mean that because it has more elements than this. No. The most important thing is that one. So what is the mathematical way to identify again a square and a rectangular matrix? By telling the order of the matrix. Which order is this? 1, 2 rows. Remember, number of rows first. How many columns? 1, 2 columns. So whenever the number of rows is the same as number of columns, we can say it's a square matrix. It could be 2 by 2. It could be 3 by 3. It could be 4 by 4. The number of rows and number of columns are the same. So therefore, it is called a 2 by 2 matrix. A 2 by 2 square matrix. Okay. So how about this one? How many rows do we have? 1, 2, 3 rows. How many columns? 1, 2, 3 columns. So the number of rows and number of columns are the same. It's a square matrix. So we can say it is a 3 by 3 square matrix. 2 by 2 square matrix. How about this one here? How many rows? Rows first before considering columns. 1, 2 rows. How many columns? 1, 2, 3 columns. Number of rows, number of columns, they are not the same. So it is not a square matrix. It is what? A rectangular matrix. So here again, how many rows? 1, 2, 3. How many columns? 1, 2. They are not the same. So it is not a square matrix. It is what? A rectangular matrix. Okay. So the next thing is unit matrix. So we can say that one is the most talked about unit matrix. Unit matrix. Um, for unit matrix, now let's say we have 1, 1, 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0. This one is called a unit matrix. Why? Because we only have non-zero here. Not only non-zeros, all the elements here are 1. Everyone here is 0, everyone here is 0, but this line is what? So, in fact, before I even explain this, I would have explained diagonal. Yeah, so let us go to diagonal quickly. Now, let's say we have 2, 0, 1, sorry, 0, 0, 3, 0, 0, 0, minus 8. Yeah. Let's say 3, 0, 0, minus 4, like this. Okay. This and this, they have something in common. Let us listen. First of all, this one is a unit matrix. This one is a unit matrix. This is not a unit matrix. This is not a unit matrix. Whenever in mathematics you hear the word unit, the first thing that should come to your mind is 1. And a unit matrix is a matrix wherein, mathematically, wherein the determinant is 1. But by appearance, a unit matrix is wherein every element is 0 except this line, and this line is called diagonal. So the fact that only this line we have elements which are not zeros, we call this one a diagonal matrix. Only this line we don't have 0, we call it diagonal matrix. Everywhere is 0 except this line, and this line is a diagonal from geometry. This one is a square, this one is a rectangle. From one corner to the opposite corner, this one is a diagonal. From one corner to the opposite corner, this one is a diagonal. From this to this is a diagonal, this is also a diagonal. But one thing about matrix, matrix does not approve this diagonal. This one is not accepted in matrix. Only the diagonal from the top left to the bottom right is the diagonal that we consider in matrix. So don't think of what about if we have something like this. No, no, no. Only this way. I hope it is clear. So a matrix where every element is 0 except the diagonal elements which are not zeros is called a diagonal matrix. This one is a diagonal matrix. So come to think of this. This one being a unit matrix doesn't mean that it is not a diagonal matrix, because it satisfies what? It satisfies the definition of a diagonal matrix wherein every element is 0 except the diagonal element. Every element is 0 except the diagonal element. So if every element is 0, but the diagonal elements are not zeros, basically, generally, it's a diagonal matrix. But if the diagonal elements are 1 everywhere, it is not only a diagonal matrix, it is what? A unit matrix. And this unit matrix, in the topic matrix, it is denoted by letter I. So in matrix, I is reserved for what? For unit matrix. It is not only called unit, it's also called identity matrix. The reason we use the letter I. So this one is an identity matrix. I hope you get it. Is this a diagonal matrix? Yes, it's a diagonal matrix. Why? Because every element is zero except the diagonal element. Is this a diagonal matrix? Yes, it's a diagonal matrix. Is this an identity or unit matrix? No. Why? Because the diagonal elements are not zeros. I hope it is clear. Okay. Now, what about this one? 2, 0, 0, 0, 4, 0. Is this a diagonal matrix? Because every element is zero except this way. This is not a diagonal matrix. Why? Because a diagonal matrix is always a square matrix. So there are three words here now. We have unit, we have diagonal, we have square. A diagonal matrix has to be a square matrix. This one is a 2 by 2. This one is a 3 by 3. This one is a 3 by 3. This one is a 3 by 3. This one, 2 rows, 3 columns. This one is not a square matrix. So because it's not a square matrix, even if you see zeros, but here is not zero, it is not a diagonal matrix. And it will never be what? A unit matrix. I hope that one is understood. Okay. Triangular. When we talk about triangular, I don't want the video to get to too much of time. Okay, triangular matrix. When we talk about triangular matrix, every element is zero except a particular pattern. Okay, but triangular matrix, we have two. We have the upper, we have the lower triangle. Okay, now let's say we have like 1, 0, 0, 3, 4, 0, 2 minus 1, 8. When you take a look at this one, look at the diagonal. Do you see the diagonal? There are elements which are not zeros. So here, can you see the triangle that I have just drawn? Look at the triangle. And here is another. 4, 3, 2, 0, 8, 1, 0, 0, 4. Yeah. Look at the diagonal elements. Are they zeros? No. And all this part, no zero. Do you see a triangle? Do you see a triangle? So when you have a triangle down, we call this one a lower triangle, triangular element. And this one is what? An upper triangular matrix. Lower triangular matrix, upper triangular matrix. I hope that one is good. All right. Singular matrix. When we say a singular matrix, a singular matrix is when the determinant is zero. A singular matrix is when the determinant is zero. And once the determinant is zero, there will be no inverse. Yeah, because for us to find the inverse of a matrix, we have to say A over the determinant before we work on the matrix. And if the determinant is zero, so this one will become undefined. So it's not possible. So a singular matrix is one in which the determinant is zero. What is a zero matrix? As the name implies, zero matrix. Every element is zero. A matrix where every element, every entry is zero is called a zero matrix. So this one I'll reserve them for the next because I don't want the video to go much time, to take much time.